Welcome to Deoxyribonucleotide Metabolism. My name is Wyatt and this is Sierra. We're going to try and go ahead and explain this little metabolic pathway for you. So we know that there's more RNA than DNA in the body, and the sole function of deoxyribonucleotides is to serve as constituents for that DNA. So this is where we're going to call in to say that DNA differs chemically from RNA in the nature of sugar and in the identity of the pyrimidine bases. This lets us focus our biosynthesis into two specific processes, the origin of deoxyribose and the origin of the thymine methyl group. To help explain the process that occurs at the nucleotide level, here's a quick overview of the deoxyribonucleoside triphosphate biosynthesis. You can see we have the ADP, the GDP, CDP, and UDP, and we're going to use the ribonucleoside diphosphate reductase, an enzyme, to kind of break it down a little, and we're going to get to the deoxyadenine diphosphates, the deoxyguanine, deoxycytosine. Those three are quite, you could call respectively, direct to get the final substrate, which is your deoxyadenine triphosphate, deoxyguanine, deoxycytosine triphosphates, through the process of using ATP, resulting in the ADP and the substrate. In order for this biosynthesis process to work, we're going to have to take ribonucleotides and convert them to deoxyribonucleotides. This reaction is possible by the catalyzation using RNR, or ribonucleotide reductase. So the most widespread form of RNR that we're going to see used is going to be the ribonucleoside diphosphate substrates, R and DPs, and reduces them to the corresponding deoxyribonucleoside diphosphates, the DNDPs. In order to have a good maintaining biosynthesis metabolic process, once the 4 deoxyribonucleoside diphosphates, the DNDPs, have been created through the RNR action, 3 of them, the adenine, the cytosine, and the guanine deoxydiphosphates, are respectively direct to the deoxynucleoside triphosphates by nucleoside diphosphate kinase. That is an enzyme along with deoxyuranine triphosphase, which is an enzyme to help minimize the acclimation of your cell DNA. So we're going to have these enzymes that are going to help us go from nucleotide to nucleotide, monophosphate, diphosphate, and triphosphates. So, for example, we're going to take the uranine diphosphate and walk it through the whole process to get deoxythymidine triphosphate. So we're going to start with the UDP, go down to, and then we're going to use that, and the process is going to break it into deoxyuranine diphosphate, which then is converted to deoxyuranine triphosphate. So that triphosphate is going to use the deoxyuranine triphosphase and a little bit of water to create the deoxyuranine DU monophosphate, so MP. We're going to be seeing a little bit of that thymidine kinase come in on that deoxyuranine, and that's going to help bring it, and the enzyme is going to help break it into that DU-MP. Once we get into the DU-MP stage, we're going to see a thymidylate synthesis come in, another enzyme, along with the 5,10-methylene THF to get DHF. And this is going to bring it down to the deoxythymidine monophosphate. Once we get to this stage, we can use thymidine kinase, ATP and ADP, to bring it and get us to the deoxythymidine diphosphate. So now we have more ATP and ADP coming back into action, and we can see it finally ending up in our substrate that we want, the deoxythymidine triphosphate. So that's kind of the general metabolic process for these nucleotides, and I hope this explanation kind of helps you a little bit. Thanks for listening, guys. If you have any questions or comment, leave them below. We'll get back to them. Hope you enjoyed it. Bye.